Now this is a typical circle problem. So in this problem, they say a 13-gram rubber stopper is attached to a 0.93 meter string. The stopper is swung in a horizontal circle, and you guys are going to do this in your circle lab, so it's kind of neat, making one revolution in 1.18 seconds. And then it says, find the tension force exerted by the string on the stopper. So we have a couple of things going on here. Let's write what we know. We know that this is our mass, and our mass is equal to 13 grams. And just like every other force problem, our mass needs to be in kilograms. So I'm going to have to divide by 1,000, and I'm just going to go ahead and do it now and get it out of the way so I don't forget to do it later. Okay, and then I have a string that is 0.93 meters long. So this is our string, and this is our circle. So the length of our string is our radius. And then we have one revolution in 1.18 seconds. So this is our period. And then we want to find the tension force. So the first thing we're going to have to do is we're going to have to find the acceleration, because they didn't give us that. So we need to find our centripetal acceleration. Now, our centripetal acceleration formula is AC is equal to V squared over R. But they did not give us V squared. And so we're going to have to use the formula that I showed you on the acceleration slide. Because we do have those things. So I have 4 times pi squared times my radius, which is 0.93 meters, divided by my period, which is 1.18. And the period is your time it takes to do one revolution. And so we've got that. Now, if we want to put all this in a, I'm going to take the top, and I'm going to solve for the top. And I also solved for the bottom. And this is what I got from my calculator. Now look, our units are meters per second squared, which is great because we're doing an acceleration. And acceleration is always going to have meters per second squared as a unit. And we end up with 26.41 meters per second squared. And this is our centripetal acceleration. Now, I feel like we've done all this work and we haven't even actually solved for what the problem was asking for. So now we can solve for force. Except this is step 2, not step 1. So to find the force, we're going to use our same force problem, force equals mass times acceleration, our force formula, except we're going to use centripetal acceleration here since we're dealing with circles instead of regular acceleration. I'm going to put my mass in. I'm going to multiply that by my centripetal acceleration. And I end up with 0.34 newtons is my force. Now, compared to projectiles, circle problems are easy peasy. So this should be an easy part for your test.